In this video, I am going to discuss the double integration method. So double integration method is one of the method that can be used in solving deflections. So sa double integration method, meron tayong equation na d squared y all over dx squared is equals to m all over ei. Itong equation na to, ito yung ating curvature. Saan ito ay equal din sa y double prime or ei y double prime is equals to m. Then, integrate natin to, magkakaroon tayo ng derivative of y with respect to x is equals to m all over ei or y prime or ei y prime equals to m. Kung saan, itong equation na to, ito na yun siya yung ating magiging slope or d theta. Then, i-integrate ba natin ulit ito? Magkakaroon tayo ng y is equals to m all over ei or ei y is equals to m. Na kung saan, ito yung equation na to, ito yung ating magiging deflection. Yan, dalawang yan. Kaya double integration yung tawag kasi kukuha tayo ng moment, then i-divide natin siya sa ei, na kung saan itong ei na to, siya yung ating modulus of rigidity ng ating structure. M para sa moment, E para sa modulus of elasticity, and I para sa moment of inertia. Kaya rin tinawag na double integration kasi dalawang beses tayo nag-integrate para makuha itong equation na to na kailangan para ma-solve yung ating equations. So ngayon, proceed tayo sa ating sign convention. Sign convention. So, bibigay tayo ng isang beam na mayroon dalawang support, isang pin, isang ruler. Then, mayroon siyang elastic curve at tangent. Ito yung ating elastic curve. Dito, ang ating slope. And syempre dito, ang ating deflection. So, napansin nyo, kapag upward tangent is magkakaroon tayo ng positive na deflection. At kapag upward, yung ating theta or slope is counterclockwise. Then, dito sa baba, kabaligtaran lang ng dalawa na yan. Dito, downward, negative, at clockwise na theta. So, ibig sabihin, kapag yung nakuha natin na slope, positive, angat yung ating tangent. Ibig sabihin, magiging counterclockwise yung magiging counterclockwise. Kapag negative ang slope, ang kanyang tangent ay clockwise. Tandaan din natin na kapag positive yung slope, positive slope, positive din yung ating deflection. Kapag negative slope, negative din syempre ang ating deflection. So, proceed tayo sa ating boundary condition. So, ganun pa rin. Meron tayong boundary condition. Meron tayong beam na may dalawang support. Lagyan natin ng load P and distance na L. So, una, ay nalagay ito. Point A, B, and C. Una, gawa tayo ng equation from point A to point B. Then, tuwin natin yung kanyang slope and deflection. So, dito, nagkakaroon tayo ng x sub 1. Then, from point B to C, kunin natin ang deflection. Then, ang kanyang magiging distance is x sub 2. Tayo na ibang ballpen. X sub 2. Tapos, dito sa A natin, sa ating at A, yung ating x is 0. Yung ating y is 0. Sa ating C naman, ang ating x is since kabuuan is itong length na to, L, yung ating y is 0. Tapos, yung ating slope dito ay hindi siya 0 kasi meron siyang support na pin at saka ruler. So yun, para maintindihan natin, magsagot tayo ng isang example. Ito. A simply supported shown in the figure carries a uniform load of 24 kN meter. Determine the slope and deflection at 4 meter from the left support using the double integration method. So ito, may beam, dalawang support, may load, may length. Una, kailangan natin kunin itong forces na to. Since meron diyang support, meron diyang reaction. So kung makapansin nyo, uniform load siya. Ibig sabihin, pag uniform load, pag ginawa natin ito siyang 24 kilonewton times meter times 10 meter is equals to 240 kilonewton. So yan ay kanyang unit load. At since nasa gitna siya, maghahati na lang tong dalawa na to. Ibig sabihin, ang value ng dalawang support na to is 120 kilonewton. Pero kung gusto mong makasigurado at solve natin, try natin i-solve gamit pag mag-moment tayo. So, summation moment at A sa clockwise is positive, so 0 is equals to clockwise negative 24 kilonewton meter times 10 meter times centroid, which is 10 divided 2, which is equals to 5. Then counterclockwise again, minus RC times 10 meters. So compute natin. Negative 24 times 10 times 5 minus RC times 10. So yun, 120 kilonewton. So ngayon alam na natin yung reactions ng dalawang to. Drawing natin yung ating elastic curve. So ngayon ito na yung ating elastic curve. Ito yung elastic curve. Slope. Tapos magkakaroon tayo dito ng deflection. At ang distance nito mula dito ay gagawin natin x. So gagamitin natin dito yung mga na-derive natin kanina. Sisimula tayo sa EI y double prime is equals to m. So mag-moment tayo. So equals 120 kilonewton times x minus 24 kilonewton meter times x times centroid na x divide 2. So, ito ay magiging 120x minus 12x squared. Then, since meron tayong nakuha ang AIY double prime, integrate na lang natin to. So, AIY prime is equals to integral nito 120 x squared all over 2 minus 12x cubed all over 3. So, simplify. Ito ay equals din sa 60x squared minus 4x cubed plus C1. AIY prime. Then, another integration. So, magkakaroon tayo dito ng AIY is equals to integral nito 60x cubed over 3 minus 4x to the 4th over 4 plus C1x plus C2. Then simplify. 20x cubed minus x raised to 4 plus C1x plus C2. Ito na yung ating equation 2. Ito yung ating equation 1. Ito yung ating mga gagamitin para sa pagkuha ng ating slope at saka deflection. Proceed tayo sa ating boundary condition. Boundary condition. So let's say when x is equal to 0, y is equals to 0. Gagamitin natin dito yung ating equation number 2. So when x is equal to 0, y is equal to 0, obviously, pag ginamit natin itong equation na to, lahat 0. Ito, 0, 0, 0, 0. Yung maritira is C2. So, C2 is equals to 0. When x is equal to 10 meters, 10, y is equal to 0, substitute again sa equation number 2. Kakaroon tayo ng 20 times 10 raised to 3 minus 10 raised to 4 plus C1 times 10 plus 0 is equals to 0. Ang value ng ating C1 is negative 1,000. And then, we can solve the rotation y prime is equal to 0 of the beam at x is equals to 4 mula sa equation 1. So, equation 1 yung gagawin natin. Ito yung ating isa-substitute. So, equation 1, EI y prime equals to 60 times 4 raised to 2 minus 4 times 4 raised to 3 minus 1,000. So, yung ating EI y prime is equals to negative 296 Newton meter squared. Ito, mga value natin. Then, tandaan natin na yung mga negative sign na yan is nagkapakita na yung ating slope ay downward. So, para naman sa ating theta, makakompute natin siya gamit yung mga nakuha nating value kanina. So, multiply natin ito dito, or EIY prime C1 cube over EI. Substitute 296. This time gagamitin natin na positive na siya, times 1,000 cube all over 200,000 times 240 times 10 raised to 6. So yun, hindi ko pala nabanggit sa problem kanina. Meron pala tayong given na EI kung saan yung ating E is equals to 200 gigapascal. Yung ating I is 240 times 10 raised to 6. So yun, sorry. Substitute lang natin yan dyan. Yan, makuha natin yung value ng ating theta. Theta is equals to 6.167 times 10 raised to 3 radians, or yan, 0 equals din siya sa 0.1053 degree. Then the deflection at x is equals to 4. Malusolve natin siya gamit yung ating equation number 2. So x is equals to 4, gamit natin equation. So equation number 2, we have EIY equals to, substitute natin to, 20 times 4 cube minus 4 raised to 4 minus 1,000, 4. So yung ating EIY is equals to EIY is equals to negative 2,976. Tandaan ulit na negative, ibig sabihin yung ating curve is below the origin. So para sa ating deflection, 2,976 times 1,000 raised to 4 all over EI, 200,000 times 240 times 10 raised to 6. Yung ating deflection ay 62 millimeter. So yun, nakuha natin yung ating slopes and deflection.